Good morning friends. Once again I welcome you all to my YouTube channel. So previous sessions we were discussing about exercise 4.3 from your matrices and determinants, that is from your determinants NCERT book, right? Also we have solved two problems. So let's continue the same thing here. Let's try to solve the third one. I have asked you people to try it, right? So if you have got it is well and good. So if you are struggling, so you can have a look at this. Okay. So what was the question is, using cofactors of elements of second row, evaluate this particular determinant. So we need to evaluate this determinant making use of cofactors of second row. So we know friends, if we want to calculate the cofactors, we should calculate minors. Okay. So cofactors of second row they have asked us to utilize. So we need to calculate minors of second row. There is no need to calculate minors of each and every element. So just calculate the minors of second row, and then with the help of that you calculate the cofactors of second row, because we need the minors to calculate the cofactors. We need the minors to calculate the cofactors. So let's not waste time on calculating minors of all the elements. Just we need cofactors of second row, calculate the minors of second row. Okay. Okay. So here elements of second row are A21, that is equal to 2, A22 that is equal to 0, and A23 that is equal to 1. And minors are given by M, capital M. M21 is how much? Living, second row and first column, right? A21 is 2, so M21 is minor of this 2. So this 2 is there in second row and first column. So leave second row and first column. So what is there? 3, 8, 2, 3. So this will be 3, 8, 2, 3. So what will be this value? 3 into 3 is 9. 9 minus 16. So 9 minus 16 is how much? Minus 7. M22, A22 is 0, minor of 0 is M22, leave second row, second column. What is left? 5, 8, 1, 3. 5, 8, 1, 3. So 5 into 3 is 15 minus 8. So this will be equal to 7. So next is M33. So M33 is, sorry, M23. Minor of A23. A23 is 1, which is there in second row and third column. So leave second row and third column. What is remaining is 5, 3, 1, 2. 5, 3, 1, 2. So here 5 into 2 is 10. 3 into 1 is 3. So this is nothing but once again 7. Okay. So now A21 cofactors, right, is given by minus 1 to the power 2 plus 1 into M21, right? So minus 1 into to the power 2 plus 1 is minus 1 to the power 3. Minus 1 to the power 3 is minus 1. So there is minus. M21 is how much? Minus 7. Minus 7. So this will be plus 7. A22 is what? Minus 1 to the power 2 plus 2 into M22. So this is minus 1 to the power 2 plus 2 is plus 1. So leave it. What is M22? 7. Right? So A23 minus 1 to the power 2 plus 3 into M23. Minus 1 to the power 2 plus 3 is minus 1. So put minus sign here, and M23 is 7. So it will be minus 7. So once again friends, last class I have said that if I plus j is even, then minus will be equal to its cofactor, right? So see, 2 plus 2 it is even, here also 7, here also 7 we are having. Okay, so if it is odd, then Mij will be equal to minus Aij, or Aij will be equal to minus Mij. So 2 plus 1 is odd. So A21 should be equal to negative of M21. Negative of M21 means this M21 is minus 7. Negative of M21 will be plus 7. Similarly, 2 plus 3 is 5, which is odd. So A23 should be negative of M23. M23 is 7, so A23 is minus 7. This is how we will get the values, right? This is how we should cross verify. Okay. So now determinant value using cofactors of second row, right? So you can write it as A21 into A21 plus A22 into A22 plus A23 into A23. This is the formula you need to use when you are asked to calculate the value of determinant using cofactors of any row or any column. So they have asked us to use the cofactors of second row. So what are the cofactors of second row? A21, A22, A23. So for A21 you multiply the element A21. For A22 you multiply the element A22. For A23 you multiply the element A23. If it is for third row, then A31 into A31 plus A32 into A32 plus A33 into A33. If it is first row, A11 into A11 plus A12 into A12 plus A13 into A13. Right? This is how we need to make use. And it can be asked through column also. Okay? Fine. So now, what is A21? 2. And what is capital A21? That is 7 plus element A22 is 0, capital A22 is 7 plus element A23 is 1 and capital A23 is minus 7. So this is what? 14 plus 0 minus 7. So I can write the value of determinant as equal to 7. Generally we are calculating determinant, right? When we use the first row, what we are doing? 5 into leaving this row and this column, this determinant, minus 3 into leaving this value and this value, this determinant. That is nothing but using the cofactors. Using the cofactors of first row. If we are calculating it second row, using the cofactors of second row, we are doing it here. Here we are calculating it separately and putting here. Okay. So in there what we are doing, directly we are using it in the formula. Okay. So this is how you have to calculate it if they ask you to do it through any row or any column. So now take a moment, pause the video and make a note of this. Okay friends, so I hope you have taken down that one, right? So we'll try to see how to solve this one. So here they have asked us to find cofactors of, using the cofactors of third column, we should evaluate this. So previous problem it was cofactors of second row. Now here they are asked to find out it through cofactors of third column. So that is yz, zx and xy. Okay. So third column elements are A31, that is nothing but yz. Okay. A31, A13, then A23 is zx and A33, that is nothing but xy. Okay, so these are the elements of third column. So we should find its minors and their cofactors. Okay, M13 is what? So M13 is cofactor of A13, which is yz. Leave the row and column containing yz, that is first row and third column. So what will be left? 1y, 1z. 1y, 1z. This is nothing but equal to z minus y. Then M23, that is zx, so which is there in second row and third column. So leave it second row and third column. If I leave, what will be left? 1x, 1z. Right? So this will be z minus x. Then M33, which is the minor of A33, which is nothing but xy, which is there in third row and third column. So leave third row and third column. What is left? 1x, 1y. 1x, 1y. So this is y minus x. Okay friends. So we have found out the minus. So let's find out its cofactor. A31 or A13. A13 is cofactor of M13. Cofactor of A13, right? So which is nothing but minus 1 to the power 1 plus 3 into M13. So this is minus 1 to the power 1 plus 3 is what? Minus 1 to the power 4, that is plus 4. So plus 4, 1 to the power plus 4, that is nothing but plus 1. So plus 1 means, leave it as it is, M13 is Z minus Y. So this will be Z minus Y. Okay, so let's write it clearly. Then A23, so minus 1 to the power 2 plus 3 into M23. So this is nothing but 2 plus 3 is odd, minus 1 to the power 5. 2 plus 3 is 5, which is odd. Minus 1 to the power 5 is minus 1. So keep minus. A23 is how much? Sorry, M23 is how much? Z minus X. Right? Similarly, A33 is minus 1 to the power 3 plus 3 and M33. So this becomes plus 1. So leave it. M33 is what? Y minus X. Alright. So these are the values of A13, A23 and A33. Now let's find the value of determinant. Determinant is given by, when we are using cofactors of third column, so the value should be A13 into, A13 plus A23 into A23 plus A33 into A33. Right? So A13 is how much? Small a13, that is YZ, and A13 is Z minus Y, plus A23 is ZX into minus of, this is minus of, okay, minus of Z minus X, or write it clearly. So this is plus, so A13 is YZ as usual into A13 is how much? Z minus Y, correct, Z minus Y, you write it, right, plus A23 is how much? ZX, okay, into what is A23? Minus of Z minus X, minus of Z minus X, plus A33 is how much? XY into what is capital A33? That is cofactor A33, Y minus X. Okay, so this can be written as YZ square minus Y square Z, and minus outside, right? ZX into Z, Z square X, right? So minus into minus becomes plus, right? ZX into X, ZX square plus XY square minus X square Y, right? XY square minus X square Y. So now YZ square minus Y square Z, okay? So, and ZX square minus Z square X, XY square minus X square Y, you are having it, right? So here if I take Y common, so what will be left? If I take Y common, so Z minus ZY, so let's not do that one. So I will rearrange this. YZ square minus we can take we'll take z square x. Okay. Right. Then, so what all things come? Y square z minus z square x. Y square z minus z square x is gone, plus, see, this one and this one is gone. Right. So we have zy square, and I can write xy square minus y square z. So this one and this one is gone. Xy square minus y square z. Okay. Plus, so what is left next? Zx square minus x square y. Zx square minus x square y. Right. So here I can take z common. So if I take z square common, what will be left? Y minus x. Plus here if I take y square common, what will be left? X minus z. And here if I take x square common, what will be left? Z minus y. So this will be one of the solution, right? So there are multiple solutions available for this, right? So you can, because they have not asked us to prove anything, you can do it up to here, or some other solution is also there, right? We can do it in other way also, which I will explain. You just take a moment and pause the video. So friends, that was one of the method, right? So it can be simplified in different way also, which I am going to show here. So as usual, y into z is yz square minus y square z, plus will not come, right? So plus into minus is minus, right? Z square x, right? So it will be z square x. Then minus into minus plus, right? Zx square. Okay. So here plus xy square minus x square y. This will be the step. Okay. This which we have done already. Okay. So now take minus yz common. Minus yz if I take common, right? So what happens? So this minus yz if I take common, what remains here? Y square z is there. If y is gone, y is remaining, right? So this becomes y, and here y is gone, yz is gone. So what remains? Minus z. So you can see minus yz into y, minus y square z, minus yz into minus z, so plus yz square. You will get back the same thing. I have taken yz common. If I take yz common, what will be there? Z minus y, right? If I take yz common, it will be z minus y. I have taken minus yz common, so it is y minus z. That's it, right? Then plus x square y minus z square x. I will take these two in a set. X square y minus z square x, right? Plus zx square minus x square y, sorry, xy square. This is, these two things are taken common. Xy square minus z square x plus zx square minus x square y. So this you keep it as it is, minus yz into y minus z. Okay. So here I can take x common. So if I take x common, what happens? Y square minus z square. So here I can take x common, sorry, x square common. So what happens? Z minus y, right? Z minus y. So this can be written as minus yz into y minus z plus x into y square minus z square, y minus z into y plus z, right? Here Z minus Y is there. If I reverse, minus will be coming out, Y minus Z. Okay, so this is how it will come out. So minus YZ into Y minus Z. So plus, right? So here we have common. So I can take common. So Y minus Z is there, Y minus Z is there, Y minus Z is there. So if I take Y minus Z as common, so what remains? Minus YZ plus X into Y plus Z. Because this Y minus Z is coming out, so X into Y plus Z will remain minus X square. Right? So what happens here? Y minus Z minus YZ plus XY plus XZ minus X square. Right? Plus XZ minus X square. So now Y minus Z is there, keep it as it is. Okay? Into, see, XY and YZ. In that what I can take? I can take Y common. So if I take Y common in these two terms, what remains? X minus Z. So if I take Y common, here X and here minus Z. Plus here if I take X common, so what remains? Z minus X. Right? So Y minus Z into, right? So I can write this as Y into X minus Z minus I will take out. So it will be what? X minus Z. Right? So this I will write here. Next step. So here Y minus Z you keep it as it is. Okay. And here X minus Z is there, X minus Z is there. I can take X minus Z common from both the sides. Right? So if I take X minus Z common, so what remains here? Y and here X. Y minus X. So this can be written as X minus Y, Y minus Z, Z minus X. See here X minus Y, Y minus X is there. So if I make it as X minus Y, 1 minus will come. And here X minus Z is there. If I make it as Z minus X, 1 more minus will come. So this, reversing this will give you minus, reversing this will give me 1 more minus. Minus into minus, once again it becomes plus. So this is how you have to proceed. Okay, so I hope you have understood this problem. So now have a moment, take a look at this by pausing the video. Okay friends, we have come up to the last problem. That is an interesting part of this exercise. So as we know that one or two problems from the end sessions will be of objective type. So this is the last problem which is given in the form of objectives. So they have given some determinant here. That is A11, A12, A13, A21, A22, A23 and A31, A32 and A33. And they have mentioned that capital Aij is cofactor of small aij. That means capital A11 will be cofactor of small a11 and capital A12 is cofactor of, that is the element A12. Similarly capital A33 will be a cofactor of element A33. So then the value of determinant is given by. So when we know the elements and their cofactors, we can calculate the value of determinant either by any elements of any row or any column of the cofactors. Right? That is, we know already, we have solved two problems on that. You can take either first, second or third row or first, second or third column cofactors of any 3 row or any 3 column, multiply it with their elements and take the summation, then you are going to get the value of determinants. Let's check out with the answers. So what are the elements here? A11, A12, A13. So A11, A12, A13 are the elements of first row. So if we are using the elements of first row, in order to get the value of determinant, cofactors of first row should be used. Let us check out A11 What is the cofactor used here? A31, right? So A11 is the element of first row. Here all the elements of first row are there, so definitely there should be all the elements of cofactors of first row only, but it is not there, right? A31 is the cofactor of third row first column. Here A32, A13, so this is not at all the option. And here A11, A12, A13. Once again, these are the elements of first row. Let us check out whether do we have the cofactors of first row. A11 is the cofactors of first row. This is correct. A21 is not the cofactor of first row. A21 is what? Cofactor of second row and first column. So this is not possible. So this option is ruled out. Coming to here, A21, A22, A23. So A21, A22, A23 are the elements of second row. So definitely we should have cofactors of second row. Do we have here? A11. This is not the element of, this is not the cofactor belonging to second row. So this option is also cancelled. So obviously we should have the fourth one. Fourth one should be right one. Let's check it out. A11, A21, A31. So A11, A21, A31. These are the elements of first column. So definitely we should have the cofactors of first column. Is it there? A11. So definitely it is cofactor of first column. A21. Cofactors of second column. A31. Cofactors of third column. So definitely it is there. So this is our right option. Okay. So this is how we need to identify it. So with this exercise is completed. So in next session we are going to start with adjoint and inverse of a matrix. Okay. So we have seen already we have seen the minors and cofactors. With the help of these minors, how to find the adjoint of A, I will explain it in the next class. Okay. So till then, take care, keep practicing, and goodbye.